The 12th question.
Construct a logic circuit that will produce logic 1 output whenever 2 or more of its 3 inputs are at logic 1.
That I already discussed.
Sir, I was not there, sir.
You repeat the question.
Construct a logic circuit that will produce logic 1 output whenever the 2 or more of its 3 inputs are at logic 1.
In the question, let me. Okay. Okay, in the question it is given whenever 2 or more inputs are 1 with having inputs of 3. Is it? Last sentence, when will you repeat? Slowly.
Whenever 2 or more of its 3 inputs are at logic 1.
Whenever 2 or more
More of its 3 inputs
of its 3 inputs.
are at logic 1.
Whenever 2 or more of its 3 inputs or logic 1.
Are at logic 1.
Okay. So here in the question it is given 3 inputs. Whenever 2 or more of its 3 input. 3 input is given. Nothing but how many inputs? There are already 3 inputs in the question it is given. Okay. So nothing but first you have to draw the truth table. Okay. Because they are asking the logical circuit. Is it or not? They need to, they are expecting
Yes,
draw the logic circuit. Okay, if I want to draw the logic circuit, first you have to need the truth table. Okay, you need what truth table you need. Okay, so in the question it is given three inputs. 3 inputs, let me take, I will take A, B, C and Y is my output. Okay, if it is 3 input in the sense, how many input combination? It becomes
8.
8. Okay, so what I will do? 0, 1, 0, 1, 0, 1, 0, 1 here. Okay, and this is 0, 0, 1, 1, 0, 0, 1, 1 here. Okay, and next is 4 zeros and 4, 1. Okay, in the question, whenever 2 or more of its 3 inputs are at logic 1. And so will you repeat the question? Whenever 2 or more of its 3 inputs.
Yes, sir, correct.
Okay, before that, before whenever.
Whenever 2 or more of its 3 inputs are at
Read from starting.
No, initially you start initially.
construct a logic circuit that will produce logic 1
Okay,
output.
okay. That is that will consider and that will develop the output 1. Okay, the Y output will becomes 1 whenever we have 2 or more of its 3 input is 1 here. Okay, in the question, in the truth table, we have a 3 input combination. First, you have to identify the more than 2 number of input is having 1. In the first row, let me take in the first row, ABC value 0, 0, 0. Okay, all the input is 0, 0, 0. Okay, but output it becomes 0 because in the question it is given whenever 2 or more of its 3 inputs are at logic 1, the output will be 1 here. Okay, because all the input is 0 means Y becomes 0 here. Can you come to the second row? 0, 0, 1. Again here C as the input C as 1 and remaining A and B will be 0, 0. For this combination of the input, again the output will be 0 here. Okay, again, come into the third row. Come into the third row. Yes, 0, 1, 0. Again, the A and C is 0 and B is only 1 here. Okay, B is 1 means again, as per your condition, whenever 2 or more of its 3 input, logic output is 1. But here Y becomes 0. But in this fourth row, B and C is 1. But A is 0. Now the condition is satisfied. So the Y will become 1 here. Okay, whenever 2 or more of its 3 input, 2 or more, nothing but B and C is 1 here. So that is what Y output becomes 1 here. Again in the fifth row, what is the output? Again it is 0.
0, 1, 1, 1.
Sixth is
1, 1, 1.
1, 1, 1.
1, 1. Okay, so this is what about the truth table here. Next is what? You have to write the expression. Okay, how will you write?
A bar BC.
A bar BC. And this one?
AB bar C.
AB bar C. And for this one?
ABC bar.
ABC bar. And for this?
ABC.
ABC here. Okay, now what you do? Overall expression for Y. Y is equal to A bar BC plus AB bar C plus AB C bar plus AB C here. Okay, so now you have to draw this circuit by using this expression. But if you know the logical, if you know the formulas, the logical expression, we can simplify here. Okay, what it is? If you know the A bar BC plus AB bar C plus here AB is common. I will take AB as common. C and C complement. This will becomes 1 as per your logical theorem. C and C bar, this is 1. Okay, so as per your logical, actually there is a postulates or theorem is there. Okay, using that theorem, this will becomes 1 here. Okay, now it will becomes A bar BC plus AB bar C plus AB. Okay, finally we got the expression. Now what we have to do? We have to write the circuit for this expression. Okay, as we see, here mute your phone. Okay,
Sir, in this we can do further simplification, no, sir?
yes. Tell me.
Sir, we can do further simplification also in this, no, sir?
You can, but it is not there. But it will take because if I want to do simplification, again I need to explain. There are so many theorems. Okay, but as per in a syllabus, the theorem is not there.
But answer will be correct, sir.
Huh?
But if we write that answer, it will be correct, no, sir?
Okay, now
Okay,
here, because in this expression we have A complement and A we have B complement, B and B complement we have. Nothing but what? I require not get here. Okay, I require not get, but C is only input C remain as it is. Okay, what I will do? I will take this is my A and this is my A bar and this is B, this is my not get, this is B and B bar here, and I make it C as it is because we don't have C complement in the expression. Okay, first expression, what it is? A bar BC. take one output of NOT gate A bar, and this is what ABC. Okay, this is A bar and this is one more C. Which gate I had to use?
AND gate.
AND gate, because it is multiplication operation, logical AND operation, sorry. It is logical AND operation, you have to use logical AND. Again, A, you take A, again B bar and C. Again, which gate?
AND gate.
AND gate you have to use. Okay. And next is final expression is what? AB. This is A, B, again, 1, 2 input AND gate here. Next, what I have to do? I am getting all the outputs of the AND gate. Finally, what I have to do? I have logical OR operation here and here. Okay, for all these things, the output of the AND, I have to connect to OR gate. So, this is my expression. This is my logical circuit. Is it clear?
Yes, sir.
So this is the circuit you have to draw based on the problem statement. We have to first you have to analyze the truth table. Afterwards you have to write the expression. After that you have to draw the circuit.
Yes, sir.
Any doubt apart from this?
No, sir.
Shall I continue the next topic of JK? JK you already know, no?
Yes, sir.
This one last
Sir, can
condition.
you bidirectional
Huh?
register? Bidirectional register.
Shift
Right.
register.
JK bistable.
Some bistables, okay, sir. Next you can go. Bistables, okay, sir. Next you can go.
Shift registers.
Yes, sir.
Is it okay now? JK bistable and everything is you understood now?
Yes, sir.
If you want repetition, I will do for this means. Someone is cast register, which is shift register or what? Who somebody asked apart from you?
No, sir. I asked bidirectional register.
Okay, shift register only.
Yes, sir.
Okay, this is register type. And what you want, you tell me, because it is some, if I want to explain from beginning, it will take more time. If you are need to specific to explain, I will explain that specific topic. Or if I want to explain all means, I can explain all. What you want, you tell me.
Bidirectional and synchronous.
Bidirectional and
Synchronous.
Sir. Synchronous and asynchronous.
okay, here actually bidirectional is nothing but here this is the logic circuit. Okay, this is the logic circuit where we are going to implement in order to shift, in order to do directional means if I want to shift this, for example, let me see here. Okay, in this, if I take it this as an example. Okay, in this example, what I am doing, I am applying this data over here. D naught. I am applying data. Again, the output will be output of the first stage. I am going to connect to the second stage of my D naught, D1. Again, the second stage of the output, I am going to connect to the third stage of my D2. Nothing but what? It is left direction. We call this as a left direction. But if I connect the directly for this example, again if I connect, this is my Q3, Q2, Q1, Q0 here. But instead of that, if I this is my D input, D and D here, this is D. But the output of the first stage, if I connect to the input directly, again the second stage, I am going to connect to the third stage. Like nothing but what? I am going to perform the operation of right direction. Nothing but what? From left to right. This is right to left. Okay, this is right to left operation. If I connect the output to the next stage of the input here, reverse order. But if I connect directly from Q3 to DS, first stage to second stage, third stage, if I connect directly, that is output to the input. So nothing but we call this as a left to right operation. Okay, nothing but if I want to make combination of left and right, I am going to use this register here, this circuits. Okay, I am going to use this circuit if I want to perform the left operation or left to right or right to left operation. At that time, I am going to use this register, this circuit. So that is what we call that as a bidirectional register. Okay. And next is it clear?
Yes, sir.
And here in the counters, counter is nothing but what? Counter is nothing but it is counting the number of events. For example, as I told, the event is nothing but take as a example of your classroom. Okay, in the classroom, if I place a one counter at the entrance, okay, it will keep on count how many people it is going to enter into my classroom here. Okay, it will count the objects. That is also we call that as an event. Counting the objects, we call that as a counter. Okay, counting the object is we call that as a counter here. Okay, how can you perform the counter? Because if I want to perform the counter, again I have two types of counter. One is called asynchronous counter. Other one is called synchronous counter here. Yeah. In this asynchronous counter, okay, if I take as an example of asynchronous counter here, in the asynchronous counter, see, I have only one clock. Okay, this is my JK flip-flop. I'm using the 3 stages of JK flip-flop here. Okay, and this output I'm going to connect to the input. There's no actually the connection is missing. This connection will be there. Okay, the output of the first stage I am connected to the second stage of the clock signal here. Again, the second stage of the output I am going to connect it to the third stage of my clock signal here. But here I am applying only one clock cycle to the first stage here. I am connecting clock signal only to the first stage. But in the second and third stage, what I am doing? I am connecting the output of the first stage to the second stage of the clock input. Okay, and similarly, the second stage of the output, I am going to connect it to the third stage of the clock input signal here. Okay, so nothing but here just I am applying the clock signal only for the first stage. I am applying the clock signal for the first stage. We call this type of signal is nothing but asynchronous counter. Asynchronous is nothing but what here? Just I am going to connect the clock signal only to the first stage. Okay, that is nothing but output will not change until the clock it is going to appear for second and third stage. Okay, in simple, I am going to apply the clock signal only for the first stage. That is what we call that as a asynchronous counter. If I want to tell synchronous, the same clock signal the connection will not be there. Let me use some color.